My dear students, now we are going to look at code converter design using multiplexer. This is lecture 30 of module 4. Now what we try to do is we will look at the truth table. Now if you look at the truth table, we will come to know what exactly you need to do. So if you look at the truth table, what exactly that we have here is I have the inputs ABCD. ABCD are inputs and XY, ZD are outputs. So what I can say is x, which is output, which is a function of a comma b comma c comma d. If I take y, y is a function of what exactly a comma b comma c comma d. If I take z, z is a function of same thing a comma b comma c comma d. Similarly for t. So I need to look in what are exactly the min terms that are there? Sigma m, what are they? Sigma m, what are the min terms for which output is 1? What is the sigma m for which output is 1? So for this sigma m for which output is 1? For that what we try to do is, we look at the input, we look at every output individually, then we try to write the expression. From those expressions I can implement using multiplexer. Now we are going to look at what is the size of the multiplexer that we require. So because the number of inputs are 4, I take a MUX, okay, and I'll take 4 selection lines to which I'll connect the inputs. So I say this is MSB, so I collect an A, B, C, D. So this is S0, this is S1, S2, S3. When there are 4 selection lines, obviously there is an output coming and there will be some inputs. How many inputs for 4 selection lines? I can calculate, which is nothing but 2 power n is to 1. So n is equals to, here is 4, as n is 4, it is 2 power 4, 2 power 4 is to 1, which is 16 is to 1 mux. To get what? To get one output. But how many outputs I have? I have 4 outputs, so I need 4 such 16 is to 1 muxes. Okay, so we will see that we can convert this. I can make a code conversion with the help of 4 16 is to 1 multiplexers. What is that we are going to apply at the input? If I want x, I will apply x as input. If I want y as output, I will apply y as input. Right? If I want z as output, I will apply z as input. If I want t as output, I will apply t as input. Whatever the input that you give, will get as an output, because the fundamental job of this circuit is connecting any one of the input to the output, right? The selector. So what we do is, we will give this input to the multiplexer. We will select based on the input. So it's very easy to do this conversion process. Now before that, what I try to do is, I will try to show you for which min terms. Say for example, if I look for x, so x is f of a comma b comma c comma d, which we have seen, which is sigma m. If I look for, see here, it is there in the table. If you look at it, is for 8 it is 1, 9 it is 1, 10 it is 1, 11 it is 1, 12 it is 1, 13 it is 1, right? 14 it is 1, then for 15 it is 1. So it is 8 comma 8 comma 9 comma 10 comma 11 comma 12 comma 13 comma 14 comma 15. Okay, what is the meaning of that is, I take a mux here, right? For this multiplexer, the inputs are, okay, A B C D, A B C D. This is MSB, This is LSB. Okay. Now what I need to do? I need to apply the inputs. So starting, so how many lines? 16 lines, right? So 1, 2, 3, 4, 1, 2, 3, 4, then 4, 4, 4 times, 8 done. So 1, 2, 3, 4, then 1, 2, 3, 4. Totally 4 times 0 to 4 been done. So totally 16. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, then 15. We are going to get as an output x. So what I am going to apply here is x as an output. For which it is 1? It is 1 for 8. It is 1 for 9. Okay. For all of these things it is 1. So what I will do is I will just connect them like this. Okay. Then I will connect it to 1. Instead of connecting individually to 1, I will connect it to 1. What about the rest? The rest what I try to do is I'll connect them to ground. So I'll do like this. I'll make a connections. I'll tie up together. I'll tie up together. This I'll connect it to ground. So that means we are applying 0 over here and we are applying 1 over here for this. This will give you the x. What is this exactly? This is 2 power 4 is to 1 multiplexer, or I can also say 16 is to 1 mux. Similarly, I can do, this is only for one output. So you need to do it the same for y, for z, for t. Okay. So just I will outline. What I need to do is, once again, for which min terms it is 1, I need to look at. For what exactly it is? For y. So once again what we try to do? For y also. Okay. What we try to do is, we want y. We want ABCD. ABCD will be, we are applying here. As usual it is MSB. It is LSB. Right. Now here we have to apply the inputs. I say this is data line or input line 0 to input line 15. So what we need to apply over here, what we need to connect over here is nothing but the values of y. Connect over here. So whichever are zeros, connect them to ground. Whichever are ones, connect it to. In this case, what I can say is, say for example 0, 1, 0, 1, 2, 3, connect it to ground. Then 4 to how much? 4 to 12, connect it to VCC. Then next 4, sorry, up to 11, and next 4, connect it to ground. So last 4 connected to ground, first 4 connected to ground, first 4 connected to ground, then in between whatever we have, that total 8 combinations, 4 combinations connected to ground, these 4 combinations connected to ground, for this 8 combinations connected to 1. Then this is also 16 is to 1 mux, you will get the output. Why? Similarly, what we need to do for Z, if you want, this 4, what are those 4? 2, 3, 4, 5 connected to 1. Then if you look at here, this 4, what are these 4? These 4 are nothing but 10, 11, 12, 13. Rest all should be connected to ground. From that what I'll get? I'll get Z. If you look at the next one, what is the next one? Is T. If you want the T, same you take the mux. Now the inputs are I0, dash 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 to I15. I am not showing the all. What I try to do is I'll connect this over here. What I mean to say is, you take the T, connect over here as an input. I want T as an output. So here inputs are A, B, C and T. The 16 is to 1 mux. Okay. By using 4 16 is to 1 muxes, what we are applying here is T. and what we are going to get is T, because it is a selector, right? So what exactly I need to do? I need to connect 1 and 2 to VCC, then 5 and 6 to 1, then 9 and 10 to 1, then what I need to do? Then 13 and 14 to 1. Rest all connected to ground. Okay. If I do that, then T I am going to get. So this is how, by using 4 16x to 1 muxes, what exactly I did, I could able to design, okay, binary to binary to the gray code converter. Okay. I hope it is clear.